Find the HCF of 21n plus 4 and 14n plus 3. A is 14n plus 3. B is 21n plus 4. B is greater than A. So divide smaller with the large. 21n plus 4 divide by 14n plus 3. 14 n's are 1's are 14n plus 3. Subtract it. This is nothing but 7n plus 1. Again further divide. 14n plus 3. 2's are. This will become 14n plus 2. Difference is 1. 7 plus n's are 7n plus 1. Remainder 0. If this is 0, 1 is the HCF for 14n plus 3, comma 21n plus 4. I hope the idea is clear. It is very simple. It is nothing but doing of find the HCF of 6 comma 15. 6 comma 15. How we did? We took the larger number. 6 2's are 12. Remainder is 3. 3 2's are 6. Remainder is 0. If the remainder is 0, 3 is a HCF of 6 comma 15. 14n plus 3, 1's are 14n plus 3. Remaining is 7n plus 1. 7n plus 1, 2's are 14n plus 2. Remainder is 1. 7n plus 1 is 7n plus 1. Remainder is 0. If it is 0, 1 is nothing but the HCF of these both numbers. 1 is the HCF of 14n plus 3, comma 21n plus 4. Idea is clear, right? So what you can do is you substitute some random value n equivalent to 1. I got 17 and next is 25. 17 and 25. 17 and 25 is nothing but co-prime to each other. N equivalent to 2. N equivalent to 2 is nothing but 28 plus 3, 31. 21 2's are 42. 42 plus 4, 46. 31 and 46. Right? They are all co-prime to each other. Or in other words, these are nothing but 7 into something, 7 into something. So the difference, the factor of their difference is nothing but 7n plus 1. Right? So from there you can determine that the factors of that number will be only one number. You take some examples to check whether are the numbers co-prime to each other or not. I hope the idea is clear. So the first one answer is 1. Second one. Very, very good questions we are going to discuss. Questions probably you have not seen in any of the textbooks. Overall are large integers. Find the largest value of GCD. We have to find the HCF of 7n minus 13, comma 13n plus 7. Take the smallest number. Largest number gets divided by this smallest number. 7n minus 13 1's are. These 7n minus 13 minus 6n plus 20. 6n plus 20 further divides 7n minus 13. 6n minus 13 1's are 6n plus 20 1's are 6n plus 20. So if I further divide minus, which is nothing but n minus 33. n minus 33 again will divide 6n plus 20. These nothing but 6 are 6n minus 138. 6n minus 198. 33 these are. These nothing but 218. 218 n minus 33. n minus 33. There will be some number like for example n by 218 minus 33 by 218. If I divide, I will get a remainder 0. So 218. 218 is the, what is the question? Largest possible value of GCD. So either it could be 218 or the factors of 218. So the largest possible value will be 218. Largest possible value will be 218 for this number. What is the largest possible value? Answer is nothing but 218. There could be the factors of 218 also, that is possible, but we want the largest possible value. It's a very simple addition. 13n plus 7 is divided by 7n minus 13. Recursively keep on doing the HCF. I got 2n minus 18. 2n minus 18 should perfectly, what am I doing is, the idea is to keep on doing it till you get an integer here. Keep on doing that continuous division till you get an integer here. Idea is to eliminate it. If that integer divides this number and gets a remainder 0, that integer or its factors will be the HCF. n by 218 cancel, so some quotient I will get here, so the remainder is 0. Idea is to continuously divide. Idea is to continuously divide till the last divisor is an integer. Please write down. Continuously divide till the last divisor is an integer. Till the last divisor is an integer. We do not know, because if it is numbers, I would have taken the factor of their difference. The question is in a linear expression. So if I subtract it also, I will get 6n plus 20. That will give the form of the number, but that does not necessarily give that answer. I hope it is clear. Continuously divide till you get an integer. Answer for this question is 218. Next one. Find the smallest possible value of n such that GCD equivalent to 1. 2n plus 75 is dividing 5n minus 73. 2s are 4n plus 150 minus n minus 223 divides 2n plus 75 2 times 2n minus 446 minus plus, it is 521 divides n minus 223. At certain value of n 521, some value will be there which will be 0. So the what will be the possible HCF? Possible HCF is nothing but 521. Possible HCF is nothing but 521. But what is the question? Smallest possible value of n. So smallest possible value, that means 2n plus 75. Smallest means when these perfectly divides and gives a remainder 0. Smallest is when 521 is equivalent to 2n plus 75. 2n is nothing but 446. n is nothing but 223. n is nothing but 223, or n minus 223 is equivalent to 0. You can also do like this. n minus 223 is equivalent to 0. 521 zeros are 0. n minus 223 is 0, or n is 223. n is 223. Smallest possible value. I hope the idea is clear. I hope the idea is clear. Next one. Next question. Please write down. As n ranges over all positive integers, how many different possible values are there for 17n plus 277? 17n plus 277 is divided by 7n plus 107. Divide it continuously. These is nothing but 2 times 14n plus 214. These minus 7n plus 63. Again it is divided, right? Divided by 7n plus 107. These 2, 6n plus 126. These nothing but n minus 19. n minus 19 divides 3n plus 63. It is 3 times 3n plus 57 minus, which is nothing but minus 57. 120. 120 is n minus 19, and so on. So what is the maximum possible HCF? 120. What are the different values? So all the factors of 120 are possible. Maximum is 120. Factors for 120 is 8 2 cube into 3 into 5. Answer is 4 into 2 into 2. It is 16. It is 16. It is 16. I hope it is clear. So it all depends upon, right? It could be how many positive integers n can take, what is the highest possible factor. It is simple. Idea is continuously divide. Idea is continuously divide till you get an integer. That is the central idea, sir. Continuously divide till you get an integer. Continuously divide till you get an integer. Now if you see here, this is 3n minus 57. This is 3n minus 57. So this will become minus and it is plus. So it is 120. I hope the idea is clear. 7n plus 107, 2s are, it is 14n plus 2, 14. So minus 3n plus 63, 2 times. I got n minus 19, 3n minus 57, 120. This is the entire idea, sir. Continuously divide the numbers till you get an integer. Continuously divide the numbers till you get an integer. Idea clear? So next one. What is the next question? Find D is the GCD of, D is nothing but the HCF of n square plus 5, comma n square plus 2n plus 6. 2n plus 6. So what you do here is, only thing is that if I take the factor of the difference, I will get 2n minus 1. But that does not give me all the values. So continuously divide n square plus 2n plus 6. It is getting divided by n square plus 5. One time n square plus 5 minus minus. So this is nothing but 2n plus 1 further divides n square plus 5. I need n square, so n by 2. This will become n square plus n by 2 minus minus. So here it is nothing but 5 minus n by 2. It divides 2n plus 1. If I take minus 4 is nothing but 2n minus 20. Minus and plus 21 divides 5 minus n by 2. With some value I will get. So what will be the values? This will take, what are all the factors of 21? Factors of 21 is 1, 3, 7 and 21. 1, 3, 7 and 21. What is the maximum value it will take? Maximum value of D is, what is the maximum value? D value is 21. Maximum D value is nothing but 21. Again and again I am saying, if the question contains variables, idea is very simple. Continuously divide till you get an integer. Continuously divide till you get an integer. That is the centralized idea. Continuously divide till you get an integer. Idea clear, right? Continuously divide till you get an integer. If the question contains variables, how to find the HCF? If the question contains variables, continuously divide till you get an integer. Continuously divide till you get an integer. I hope the entire idea is clear, right? HCF, all the problems are clear. Variables, if variables are given, how to find out the HCF, right? All these problems, I hope it is clear. Now yesterday we have discussed this question, but I did not discuss the second variety. Please take this question. A plus B plus LCM of A comma B equivalent to 18. Now see, I want to generalize it. Let me generalize it by taking a question. Please take down, sir. question. A plus B plus LCM of A comma B equivalent to 22. A comma B are natural numbers. How many values A comma B can take? A plus B plus LCM of A comma B is 22. A and B are natural numbers. How many values A comma B can take? Now see here. Right hand side, there are two cases. RHS composite, RHS prime number. Two cases we will discuss. Listen carefully, sir. Solution. A plus B plus LCM of A comma B equivalent to 22. A is HX, B is HY. This will become HX plus HY plus LCM of HX comma HY equivalent to 22. HX plus HY. H is the coprime. Coprime I can take out. Remaining H is the HCF of the numbers. X and Y are coprime. So H into X into Y equivalent to 22. H into X plus Y plus XY equivalent to 22. This can be written as, I hope it is clear, right? H into X plus Y. This can be written as 1 into 22, 2 into 11, 11 into 2, and 22 into 1. Am I right? These are the cases. What are the factors of 22, 1, 2, 11, 22? Idea clear? A HX, B HY. HX plus HY plus LCM of HX comma HY is 22. So H common. X plus Y plus XY equivalent to 22. Now see here. Now what is important is this example. Case 1. If H is 1, X plus Y plus XY equivalent to 22. If I add 1, X plus 1 into Y plus 1 is 23. 23 is 1 into 23, 23 into 1. It will make X value 0. This will make Y value 0. This case is not possible. That means if the number X plus Y plus XY on adding 1, if it is giving prime number, I will not get the answer. I will not get the answer. Suppose if it is 2, check the case. H is 11. X plus Y plus XY, it is equivalent to 2. 1 plus X into 1 plus Y, it is 3. 1 into 3, 3 into 1. Not possible. If this number on adding 1, it is giving a prime number, then it is not possible. 1 on adding 1, it is giving a prime number, not possible. This is not possible, this is not possible, this is not possible. The only case possible is H is 2 and X plus Y plus XY equivalent to 11. Till here, I hope the idea is clear. I hope the idea is clear, right? H is 1, X plus Y plus XY is 22. On adding 1, 23. 23 is a prime number. It contains only two factors, 1 into 23 and 23 into 1. In both the cases, X is 0, Y is 0. Not possible. 2 on adding 1, it is 3. Not possible. 1 on adding 1, 2, it is not possible. Exactly, that is what I wanted to tell you. So the finally question came up to H equivalent to 2, X plus XY, Y plus XY equivalent to 11. Now we will take it up. This question became A plus B plus LCM of A comma B equivalent to 22. These is nothing but H equivalent to 2, X plus Y plus XY equivalent to 11. Now add 1. X plus 1 into, why are we adding 1? If the degree of the variable is 2, write the equation as a product of two factors. X plus 1 into Y plus 1 is nothing but 12. it is nothing but 12, which is nothing but 1 into 12, 2 into 6, 3 into 4, 4 into 3, 6 into 2, 12 into 1. The first case will make x plus 1 0. Last case will make y plus 1 0. So the case will be x will be 1, y will be 5. Or x will be 5, y will be 1. X will be 2, y will be 3. X will be 3, y will be 2. When h value is how much? 2. Let us check it out. What will be the number? Number is nothing but hx and hy. A is nothing but 2 ones are 2. B is nothing but 2 5s are 10. 2 plus 10, 12. 12 plus LCM of 2 comma 10 is 10. 12 plus 10 is 22. Perfect it is. Right? Or A can be 10 or B can be 2. What is the next case? A can be 4 or B can be 6. Or A can be 6 or B can be 4. What will be the answer? Total values A comma B can take is nothing but 4 values. Idea is clear? I hope how to solve this kind of questions by using hx comma hy. I hope the idea is clear. 2 or 3 problems will solve, then you will get the idea very soon. Right? Your pen will also move fast and you will not consider this problem to be a tough problem. I hope the idea is clear. So these are the 4 values A comma B will satisfy the equation. These are the 4 values. We will do one more example. Right hand side, right? What is the important conclusion that we have seen? Important conclusion we have seen is x plus y plus xy question equivalent to 18. X and y are natural numbers. How many values x comma y will take? X plus y plus xy equivalent to 18. Xy are natural numbers. How many values x comma y will take? Right hand side, if I add 1 to it, if I get a compo prime number 19, directly answer is 0. 1 into 19, 19 into 1. X is becoming 0, y is becoming 0. So answer is no value. Answer is no value. X plus y, right? Directly you can say, based upon this conclusion, 96. Xy are natural numbers. How many values xy will take? If I add 1 to it, x plus 1 into y plus 1 is 97. 97 is a prime number. 1 into 97, 97 into 1. Answer is no value. Very important conclusion, sir. Very important conclusion. Right hand side, if the value plus 1 is giving you a prime number, if it is value plus 1, if it is giving a prime number, answer will be no value. Right hand side, value plus 1, if it is giving a prime number, answer will be no value. Idea clear? Perfect. Right. Now, right hand side we have taken a composite number. Let us take one more number. A plus B plus LCM of A comma B equivalent to 25. 25. A and B are natural numbers. A and B are natural numbers. How many values A comma B will take? How many values A comma B will take? A is hx, B is hy. So this is hx plus hy plus LCM of hx comma hy equivalent to 25. H into x plus y plus xy equivalent to 25. Equivalent to 25. 1 into 25. 5 into 5. 25 into 1. This case on 1, adding 1 to 2 is a prime number. It is out. Case number 1. H is 1. X plus y plus xy equivalent to 25. If I add 1, x plus 1 into y plus 1 equivalent to 26. 26 is 1 into 26. 26 into 1. 2 into 13. 13 into 2. Right? First case out, last case out. So here I got two cases. Here I got two cases. Or in other words, 26 is 2 into 13. 2 into 2, 4 factors. Subtract 2 factors where it gives you, right, x value 0, y value 0. Case 2. Case 2. H equivalent to 5. X plus y plus xy equivalent to 5. Adding 1. X plus 1 into y plus 1 equivalent to 6. These are nothing but 2 into 3. 2 2s are 4. Minus 2, 2 cases. What are that cases? 1 into 6, 6 into 1. 2 into 3, 3 into 2. These out, these out. Answer is 2. 2 plus 2. So the answer is 4 cases. I hope the idea is clear. Kindly reply in the live chat if the idea is clear to you. I am sure the idea should be extremely clear to you. Idea is extremely clear. Right hand side is a composite number. Let me take right hand side a prime number. Idea remains the same. Sometimes the cases will be more, sometimes the cases will be less. Right? Number of ways of writing a number as a product of two variables is always the number of factors. 2 into 2, 4. 2 cases will give you x0, y0. That case is eliminated. Idea is clear. Last problem under this case. What if the right hand side is a prime number? A plus b plus LCM of a comma b is 13. A and b are natural numbers. A and b are natural numbers. How many values A and b can take? A plus b plus LCM of a comma b is 13. A is nothing but hx, b is nothing but hy, h into x plus y plus xy equivalent to 13. This is 1 into 13, or it is 13 into 1. The second case is eliminated because x plus y plus xy is 1. On adding 1, I am getting x value 0 or y value 0. Or y value 0. These eliminated. First case, h equivalent to 1, x plus y plus xy equivalent to 13. X plus y plus xy equivalent to 13. So if I add 1, 1 plus x into 1 plus y equivalent to 14. 14 is nothing but 2 into 7. 2 2s are 4. Minus 2 cases. So answer is nothing but 2. Answer is nothing but 2. Kindly reply in the live chat once this idea is clear to you. On what basis you are eliminating the values? You are eliminating the values when x and y takes 0. You are eliminating the values if the right hand side, if you add 1, if you are getting a prime number, you are eliminating that case. You are eliminating that case. I hope the idea is clear. I hope the idea is clear. Kindly reply in the live chat. Praveen, kontam water bettu. Co-primes. What are the concepts that we... Water. Right? What are the concepts that we discussed under co-prime? It is just a 5 to 10 minutes topic, sir. Because already we have discussed HCF of a comma b equivalent to 1. A and b are said to be co-primes. A and b are said to be co-primes. First point, sum of two co-primes is given by phi of n by 2. Product of two co-primes is given by 1 by 2 into 2 power p. Yesterday we have seen count of prime bases. What is phi of n? Phi of n is n into 1 minus 1 by p1, 1 minus 1 by p2 1 minus 1 by P3. Already we have discussed a lot of problems. Just a simple application, sir. P1 power A, P2 power P and P3 power C. P1, P2, P3, they are all prime numbers. They are all prime numbers. They are all prime numbers. All the problems are based upon this concept. You don't need to mug up these quotient function. Already I told you how these formulae is derived. These quotient function. Now see, all the problems will solve based upon this one. Find the number of positive numbers. Number of positive numbers which are co-prime to 15 and less than 15. Co-prime to 15 is HCF of A comma 15, it will be 1. A is less than or equivalent to 15. This is nothing but HCF of A comma 3 into 5 is equivalent to 1. So out of 15 consecutive natural numbers, for every 3 consecutive numbers, one number is divisible. How many are not divisible? 1 minus 1 by 3. Out of every 5 consecutive numbers, one number it is divisible. How many are not divisible? 1 minus. This is nothing but 15 into 2 by 3 into 4 by 5. Answer is nothing but 8. There are 8 numbers which are co-prime to 15. He also said list all of them. If I have to list all of them, 1 will be co-prime to 15. Next is 15 complement of 1. 15 minus 1 is 14. 2 is co-prime to 15. 15's complement 13. Right? 15 cannot be divisible by 3 and 5. No. 4. 15's complement 11. It cannot be 5. It cannot be 6. 6 is a multiple of 3. 7. 7 means 15 complement 8. 7 comma 8. These are the numbers. I hope it is clear. Why? Because 1 plus 14 will give you 15. 2 plus 13 will give you 15. 2 plus 13 will give you 15. I hope the idea is clear. Idea is clear. So these are the numbers. First one, very easy question. Second one, find the number of positive integers such that these is nothing but a quotient function. These is nothing but a quotient of 2015. 2015 is nothing but 5 into 403. These is nothing but 5 into 13 into 31. 31. So 2015 consecutive numbers. For every 5 consecutive number, one number it is divisible. For every 13 consecutive number, one number it is divisible. For every 31 consecutive numbers, one number it is divisible. Quotient means it should not be divisible by 2015. I hope it is clear, right? So these nothing but 2015 into 4 by 5 into 12 by 13 into 30 by 31. These 48, it is nothing but 1440. So this question I will rephrase it, write it such that 2015 is how much? Otherwise, the question interpretation will only be different. 5 into 403. 5 into 13 into 31. 5 into 13 will be 31. Right? I hope it is clear. Idea clear, right? Or even if it is, okay, these one. If the question is like this, if the question is quotient of n equivalent to 2015, find the value of n. Find how many positive integers. If the question is like this, let us keep the same question. Quotient of n is 2015. Please write down a concept. Write down a concept. Quotient function quotient function always returns an quotient function always returns an even value except n equivalent to 2. Please write down. Quotient function always returns an even value except n equivalent to 2. Suppose let us take an example. N equivalent to 13 I will take. What is the quotient of 13? 13 into 1 minus 1 by 13, which is 12. 13 is a prime number. Suppose if I take 25, 25 is 5 square. Quotient of 25 is 25 into 1 minus 1 by 5, 4 by 5, which is again 20 even number. If n is 2, quotient of 2 is nothing but 2 minus 1, 1. Only one natural number is less than 2 and co-prime to 2. So, except 2, every other quotient function, the output will always be an even number. Output is an odd number. Output is an odd number. There are no positive integers of n. No value n can takes. No value n takes. No value n takes, such that the quotient function is an odd number. Quotient function always returns an even value except n equivalent to 2. Except n equivalent to 2, quotient function always returns an even value. It always returns an even value except n equivalent to 2. Find the number of positive numbers which are co-prime to 30. That means HCF of a comma 30 equivalent to 1. It should co-prime to 30 and less than 30 it should mention. There can be a lot of numbers which are greater than 30 and co-prime, the set might lead up to infinite. HCF of a comma 30 equivalent to 1, a less than or equivalent to 30. So HCF of 2 into 3 into 5 equivalent to 1. 30 into 1 by 2 into 2 by 3 into 4 by 5. Totally there are 8 numbers which are co-prime to 30. How to write? First 1 is co-prime. The 30, 1 is co-prime. Next it's, what is its complement? 29. Okay, or otherwise sum of all such numbers, sum of all the numbers that are less than or equivalent to n, sum of all the numbers that are less than or equivalent to n and co-prime to n, and co-prime to n is given by n by 2 into phi of n, n by 2 into phi of n, 30 by 2 into phi of 30 is nothing but 8. Answer is 120. Answer is nothing but 120. I hope it is clear. Why it is n by 2 into phi of n? I don't know whether you remember this example which I said. HCF of a comma 12 equivalent to 1. A less than or equivalent to 12. Quotient of 12 will be 12 into 1 by 2 into 2 by 3, which is 4. There are 4 numbers that are less than 12 and co-prime to 12. That numbers are 1, 5, 7 and 11. 1, 5, 7 and 11. If I do reverse, this will become 11 plus 7 plus 5 plus 1. 2s is nothing but 12 into 4. S is nothing but 12 by 2 into 4, which is nothing but n by 2 into quotient of n. 12 is n, 4 is nothing but quotient of 12. So Sn is nothing but n by 2 into quotient of n. N by 2 into quotient of n. N by 2 into quotient of n. Sum of all the numbers that are less than or equivalent to n and co-prime to n is given by n by 2 into quotient of n. N by 2 into quotient of n. Please remember, do not get confused. Phi of n represents the number of numbers. Phi of n number of numbers co-prime to n. Number of numbers which are co-prime to n and less than or equivalent to n. Phi of n by 2, it will represent sum of two co-primes. In how many ways can you write the number as a sum of two co-primes? N by 2 into phi of n, it is nothing but sum of all the numbers that are less than or equivalent to n and co-prime to n. That are less than or equivalent to n and co-prime to n. Don't get confused. Three important concepts in co-primes. Quotient of n, quotient of n by 2, n by 2 into quotient of n. I hope it is clear. Number of numbers which are co-prime to n less than or equivalent to n, sum of two co-primes, sum of all the numbers less than or equivalent to n and co-prime to n. I hope the concept is clear. In how many ways 48 can be written as a sum of two co-primes? 48 is 2 power 4 into 3 power 1. Phi of 48 is nothing but 48 into 1 by 2 into 2 by 3, which is nothing but 16. 16 by 2. Answer is nothing but 8. Sum of two co-primes is given by phi of n by 2. Phi of n by 2. Easy substitution. How many numbers from 1 to 120 are co-prime to 120? These is nothing but HCF of a comma 120 equivalent to 1, a less than or equivalent to 120. These is nothing but a comma 2 cube into 3 power 1 into 5 power 1 equivalent to 1. This is method 1. I will tell you method 2. 120 into 1 minus 1 by 2, 1 minus 1 by 3, 1 minus 1 by 5. 6 5s are 30, 30 4s are 4 4s are 16, 16 2s are 32. 16 4 4s are 16, 16 2s are 32. Method 1. In case if you forget these formulae, the circle represents the numbers which are divisible by 2. This circle represents the numbers which are divisible by 3. Circle represents the numbers which are divisible by 5. Which are divisible by 5. Total there are 120 numbers. This is the value which I require. How many are divisible by 2? 60 are divisible. How many are divisible by 3? 40 are divisible. How many are divisible by 5 till 120? 24 are divisible. 24 are divisible. How many are divisible by 2, 3 and 5? 30. It is nothing but 4. How many are divisible by only 2 and 3? 2, 3 is 6. 6 means 20. Already 4 is there. It is 16. How many are divisible by 3 and 5? 15. 15 means 8 are there. So these 8. How many are divisible by only 2 and 5? 10. 10 means 10 12s are. It will become 8. 16 plus 20. 20, 28. This will become 32. 16 plus 8, 24. This will become 16. 8 plus 8, 16. This will become 8. This will become 8. Now you can solve these. What is this one? 8 plus 8, 16. 16, 16, 16. 48. 48 plus 8, 56. 56 plus 32. 88. So 88 plus x is nothing but 120. X is nothing but 32. You can also do by using Venn diagram approach. You can do it by using Venn diagram approach. What is Venn diagram? First I have drawn a circle which are multiples of 2. Then I have drawn a circle which are multiples of 3. Then I have drawn a circle which are multiples of 5. How many multiples of 2 are there till 120? 2 60s are 120. So I wrote 60. How many multiples of 3 are there till 120? 40. How many multiples of 5 are there till 120? 24. 60, 40, 24. How many multiples are common to 2, 3 and 5? 2 3s are 6, 6 5s are 30, which is 4. How many multiples are common to 2 and 3? 6. 6 means total 20. 4 is there. So it is nothing but 16. Similarly, how many multiples are there for 3 and 5? 15, 8. 4 inside, 4 outside. 10. 10 means 12. 4 inside, 8 outside. I hope the idea is clear. I hope the idea is clear. Quotient means number of numbers less than or equivalent to n. Less than or equivalent to n and co-prime to n. That is a quotient function. I hope the idea is clear. Answer is 32. Which of the following numbers, in how many ways can the numbers can be written as a product of two co-primes? Already we discussed yesterday. Product of two co-primes. Product of two co-primes is given by the logic 2 power p divided by 2. Yesterday's class I told you p is nothing but the count of prime bases. P is nothing but the count of prime bases. Count of prime bases. So it is nothing but 30. 30 is 2 into 3 into 5. So 3 prime bases are there. 2 cube by 2, 8 by 2, 4. Second one, 48, which is 2 power 4 into 3. 2 prime bases are there. 2 square by 2, 4 by 2, 2. 60. 2 square into 3 into 5. There are 3 prime bases are there. 2 cube by 2, 8 by 2, 4. Already we have discussed yesterday. Product of two co-primes is given by the logic 2 power b, entire half should be divided if the variables are not present in the question. If the variables are not present in the question, use unordered pair. If the variables are not present in the question, use unordered pair. Use unordered pair. This is the notation for an unordered pair. This is the notation for an unordered pair. I hope the idea is clear. Already we have seen the yesterday, this set A formed. Yesterday this question we have solved. HCF is 3. These also we have solved. How many numbers in the set are co-prime to 10? What are the numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. First I will tell you a traditional method. 13, 14, 15, 16, 17, 18, 19, 20. How many are co-prime to 10? How many are co-prime to 10? 10 is nothing but 2 and 5. How many are not divisible by? Co-prime to 2 means HCF of that number with 2 should be 1. How many are not divisible by? 2 and 5. How many are not divisible by? 2 and 5. Out of 20 consecutive numbers, every 2 consecutive number, one number is divisible, one number is not divisible. Out of every 5 consecutive numbers, one number is divisible by 5. You see, for every 5 consecutive, one number it is not divisible. 20 into 1 by 2 into 4 by 5, which is nothing but 8. Which is nothing but 8. Or you can also do by using Venn diagrams. Venn diagrams. Venn diagrams. Total how many numbers are there? 20. 10 is nothing but 2 into 5. 10 is nothing but 2 into 5. So how many are divisible by 2? How many are divisible by 5? How many are divisible by 2 and 5? Remaining will be the answer. Now if you see here, how many are divisible by 2? Which is nothing but 10. How many are divisible by 5? Which is nothing but 4. How many are divisible by 2 and 5? 10. 10 means 2. These is nothing but 8. These is nothing but 2. 8 plus 2, 10, 10 plus 2, 12. This value I require, 8. I hope the idea is clear. I hope R co-prime to 10. Co-prime to 10 is, they are not divisible by 2 and 5. Delete the numbers which are divisible by 2. Delete the numbers which are divisible by 2. Delete the numbers which are divisible by 5. If I delete the numbers which are divisible by 5, how many are left? Please see, that itself is the answer. Simple counting based. If I do this one, how many we got? 1 we got. If 1 we got, 19 also we will get. We got 3, we will get 17. We got 7, we got 13. So 1, 2, 3, 4, 5, 6. We got one more number, 9, and it is 11. Total 8 numbers we got. I hope the idea is clear. How many numbers of from 1 to 20 are co-prime to 10? Co-prime to 10 means 2 into 5. They are not divisible by 2 and 5. Write down 20 consecutive numbers. For every 2 consecutive, one number is divisible. How many are not divisible? 1 minus 1 by 2. Out of 5 consecutive, one number is divisible. How many are not divisible? 1 minus 1 by 5. 20 into 1 by 2 into 4 by 5. Idea clear? Next one. Now I think similarly you can solve this question, right? How many numbers in the set? How many numbers in the set? 1, 2, 3 till 30 are co-prime to 10. Are co-prime to 10. 10 is 2 into 5. So out of 30, one number is divisible by 2, 1 minus 1 by 2. One number is divisible by 5, 1 minus 1 by 5. 10 threes are totally 12 numbers we got. Total 12 numbers we got. What are that numbers? First it can be 1. Next it will be 30's complement of 1. Right? So 1 plus 29. 2 it is not possible. 10 is 2 into 5. Next it is 3. 3 and 27. It is possible. 4 is divisible by 2. 5 is divisible. 6 is divisible. 7 is nothing but 23. 8 it is not. 8 is divisible by 2. 9 and 21. 9 and 21. 11 and 19. 13 and 17. 1, 2, 4, 6, 8, 10, 12. These are the cases. So what will be the answer? Sum of the numbers will be n by 2 into phi of n. N by 2 into phi of n. 30 by 2 into 12. So answer is 180. Answer is 180. Why it is 180? Sum is 30. Sum is 30. 30, 30, 30, 30, 30. 30 into 6. Answer is nothing but 180. I hope the idea is clear. I think till here also, how many numbers are co-prime to 30? 30 is 2 into 3 into 5. So 1000 into 1 by 2 into 2 by 3 into 4 by 5. 2 3s are 6, 6 5s are 30. 30 goes how many times? 33 point something into 8. So 33 into 8. Or in case if you want to do it, you want to check why these is giving, you do the Venn diagram. If I do the Venn diagram, it should be very clear and it will result in an integer. These n of 2, that also will give you answer n of 3 and it is n of 5. N of 5. Now see here. How many numbers are divisible by 2 till 1000? Total 1000 numbers are there. It is 500. How many are divisible by 3 till 1000? 333. How many are divisible by 5 till 1000? 200. How many are divisible by 2, 3 and 5? 6 5s are 30. 30 will be 33. 33 30s are 990. How many are divisible by total? 2 and 3, 6. 6 means 6 ones are 6. 40, 6 6 are 36. 166. 166 means it will be 133. How many are divisible by 15? 15 will be 15 6 are 66. Again it is 33. How many divisible by 2 and 5? 10. 10 is 100, which is nothing but 67. I hope the idea is clear. 67 plus 33, 100, 233. This will be 233, 267. This is nothing but 133 plus 66, 199, 199, which is 134. I hope the idea is clear. 4 plus 3, 7, 10, 13. 67 plus 66, 133. 133, this is nothing but 67. This is nothing but 1000 minus of. How much it will become? 67, 67, 134. 134 plus 134, which is 268, plus 66, plus 133, plus 267. Idea is clear, right? Either you can take that value, whether you are in doubt, sir, I am getting in decimal, what we should do it? Check the value, check whether it is 234 or not. 234 or not. So 267 plus 133, which is nothing but 400. These is nothing but 354. 334. 334 plus 400, which is 734. 734 is nothing but how much you are getting? 33 point something. 260. 1000 minus 234. 266 point something you are getting it. Just calculate these values. 1000 into 1 by 2 into 2 by 3 into 4 by 5. 6 5s are 30. 33 means it is 33.3. 33.3. So how much it is? 3 8s are 24. 3 8s are 24. 26. 266.4. So answer is 266. Ignore the decimal in the answer. Either you can use Venn diagram or you can use the greatest integer function, right? Take the value 33.3 into 8, whatever the answer is there, apply the greatest integer value. Apply the greatest integer value, you will get the answer, right? Apply the greatest integer value, you will get the answer. Idea clear, right? Venn diagram approach and this approach.